Hello, physics students. Mr. Steenerson here. I want to go over this example problem of a person riding an elevator, how to set it up and how to solve it if we're given the person's mass, in this case is 70 kilograms, and also the acceleration and direction of that acceleration in the problem. So a big hint about solving these problems is we want to start with a free body diagram. And so I'm sketching that out on the side here, and I'm labeling the fact that there is a acceleration upwards of 2 meters per second, so positive 2 meters per second, and the weight force is downwards. And I already know that weight is mass times the acceleration of gravity, so I can just put that number in. In this case, it's 700 newtons, multiplying 70 times 10. The other force that we have to investigate is the force of the floor of the elevator pushing back upwards against the person. That normal force, in this case, must be greater than the weight force, so I'm going to draw a bigger arrow because I know the normal force is going to be the force pushing up, and in that direction there's a net force that causes the acceleration. So therefore this force must be larger than the weight force in order for there to be a acceleration upwards or a net force upwards. So what are some key things to think about with this? Because I know the normal force is not 700. If it was 700, there would be no acceleration. So some key things to think about is that net forces cause accelerations. Therefore, when I see acceleration in the problem, I know I'm going to look for an equation of net force. And I also can find out what that net force is by taking the mass times the acceleration. In this case, it's 70 times a positive 2. So I know the net force in this case is going to be 140 newtons directed upwards. If I want to find things that make up that net force, because remember, the net force is the sum of all the individual forces. So if I want to find, in this case, the normal force, which is makes up that net force, I can then investigate the net force itself is a combination of normal force, Fn, and the weight. They're in opposite directions, and the weight force of the gravity is downwards. So therefore, I'm going to subtract the gravity and set that equal to 140. So the normal force minus 700 is equal to 140. Remember, the 140 was from the mass times the acceleration, which is the net force. So basically what I want to figure out is how much do I have to subtract in order to get 140. So a way to do that is to add 140 plus 700. I know that difference then is the 840 is the value of the normal force. If I subtract 700 from that, I'm going to get 140 newtons. Hopefully this helps solve and set up these problems. The other thing that we talk about is what would the person feel? If that normal force is greater, if it's 840 newtons, then that force is being pushed against the person from the floor of the elevator. They are going to feel much heavier than normal. Because remember, their gravitational normal force is just 700. So they're going to feel that extra 140 newtons of weight, and that will cause them to feel heavier. Thanks, and have a great day.